Episode of the Edifice Complex podcast is brought to you by Tether. Get smart, get tethered. Blue Rhythm commissioning software and Sensor Suite, the future of intelligent buildings.
Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here again with my colleague, official agitator, friend, and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, Sir Yoda.
Hello there. Am I looking forward to this? So I've always wanted to work on a Supertall building. 39 years in, I've never made it. It's just luck, right? So I'm living vicariously through Peter here. So this would be a good interview for me.
Yeah, so back for an encore discussion on his newest book on the design of tall buildings, among other sidebars we're going to certainly have today. It's Dr. Peter Simmonds. Welcome back, sir.
Hello.
Peter, you worked all over the world on some of the most challenging architecture in a role that most would not envy. That is to draw attention to and remove the design landmines which exist between concepts and ultimately occupant satisfaction. You have more war wounds than most people that I know, and I think you actually delight in the skirmishes that you have participated in, and that's likely a legacy from your days playing football, I suspect. Since the last time we talked, the world has been turned upside down by a pandemic. And that's forcing, of course, our global society to look critically at the indoor environmental quality inside buildings. I got to ask you, are you having a I told you so moment right now?
Yes, I am. I told you so. Yeah. It's a good way to start with the finish, isn't it, really? I told you so. There's a great English or actually Irish comedian called Spike Milligan, and he put on his gravestone, he said, "I told them I was ill." So I guess that's my I told you so. No, I think, I'm going to go back in the years when we all started, when I started in this. One of the things I promised myself I would never say is that, turn around to someone and say, when I was your age, I was doing this. The good thing about getting old is and being semi-retired is that you can remember things, right? What you've done, you know what room of the house you're in or what you're doing. But when you turn around, and I try and bite my lip, but again, it's just the fact of how can you explain 40 years of experience, good and bad, or let's say bad and good, to someone who's a much brighter spark than you are, who's extremely clever, has come out and knows every button to press on the computer, right? But has no common sense.
Yeah.
Right? How do you do that? How do you guide someone and nurture someone through this is what we need to do and what we do? So if I turn around and say, when I was your age, and the sarcastic little shits these days turn around and say, well, there were no computers when you started off. I actually found a photograph of us in the first days. And I was that bad at drawing, they wouldn't even let me draw. So that's how I got into calculations, because I couldn't do it for anything. So, and I had a calculator, and that was it. And so we started. We didn't have one of these computers that you just press all the buttons, get all the answers out.
Yeah, that makes you drill down on the fundamentals, right? When you have to start that way.
I call them simulation jockeys because they all press the number. There's some fantastic programs, and I rely a lot on the programs. I try and understand them. But I think one has to try and understand. Imagine you're on a desert island. You're marooned on a desert island, but you have your calculator. You don't have a phone. You have a calculator, and you have a stick, and you have all the sand. So you can do all the math and do it. How do you do that? How do you get to the end? How do you design a building by fundamentals, right?
Yeah.
And I actually got pulled over the coals by working for a very, very reputable company in the whole world, of saying that this student I had working for me, I'd said about exactly the same thing. You're on a desert island now, blah, 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 blah. And went and complained and said I was being cruel because she knew she had a computer. She could work the computer. So how do you get the philosophy out of that?
Yeah.
You know, so anyhow, sort of divulging slightly. So do you want to get back to the subject?
Well, it's funny that you say that, Peter, because being on social media and having a bit of a presence, you open yourself up to dialogue. And I had an individual who's working on his Ph.D. thesis said, I'm working on my PhD thesis. I'm going to prove that your philosophies and design theories are wrong. And I said, well, good for you. When you've spent 35, 40 years dealing with angry customers, and if you can, in 35, 40 years, prove that you're right, I'll be dead. So good for you.
Oh, yeah. Yeah, remind me, you should do motivational speaking, shouldn't you? Really? Yeah. By the time you learn it, you'll be dead. Yeah.
So you're right. Experience teaches us a lot, and you can get bright academic minds that are doing some very interesting stuff in a box. But until you have to deal with an angry customer, a budget, right? Developers, law, the whole gamut. You're not in the real world, at all. Yeah. And it's only until you develop those scars, the bruises to your ego, to everything else, angry spouses, kids that want your attention, but you can't give it to them because you're working till 3, 4 in the morning trying to resolve stuff. That's the real world.
Yeah, they don't tell you that at university, I find.
No, you're absolutely right. They don't learn that at university, right?
No. And that's very important, because let's take these simulation jockeys now. They know everything, all the numbers come out there. Is how is it presented to a group of people? We have to realize, let's face it, the buildings we're talking about these days that I'm lucky or unlucky enough to work with, and I don't want to brag here, we're talking at least of $200 million upwards, right? Some of these other ones are massive. So you've got a person making an investment on one side of the table. Where's his money going to go? You've got someone going. So when you come up with a new idea, and let's launch upon our radiant floors and radiant ceilings and active beams and buzzwords, things that they've never seen or possibly never heard of, and they've got so much money on the table, and you're trying to sell an idea, something that works. You know that you've done it before, you've done it there, but you're the only one around the table. So how do you convince these people? You're like a second-hand car salesman sometimes. Yeah. Oh, it's really good. Just take it around the block. It'd be great. You know what I mean? But don't put it in 4th gear. You can't. How do you convince these people? And how do you bring the simulation programs and the numbers and everything else and X number of years of experience into simple logistics that these people turn around and say, okay, we're going to go ahead with this investment. And you guys know, how many buildings are there? How many buildings do we see which are just exact vanilla copies of a building that were done 10, 20, 30 years ago because the investor or the owner or even the maintenance people, the facilities people did not want anything new to rock the boat.
Oh, absolutely. That happens all the time. That is very frustrating.
I don't know how much I'm allowed to go online here. You might have to hit this up. We were doing. I was involved in doing a new concept for a rather large airport in San Francisco, and it was supposed to be the new part of it. And we went ahead and we were looking at everything. Part of what we were discussing about, the old days of Bangkok, and we looked at the space and we looked at the glass and we've done everything, and they want to be sustainable. So what came out? Displacement ventilation, radiant floors, mostly for cooling, etc., large glazing. Met the architect to do everything like this. And at the end, it got bombed by the facilities people that turn around and says, no, we don't want that. We've got rooftop package units on the rest of ours. So we want to have a standard of what our maintenance issues are going to be throughout the building. And there, in one fell swoop, forget sustainability, forget being intelligent, forget being anything. You might as well throw everything away. I mean, the biggest thing there when we talk about money is you want to turn around to the client and say, you just wasted now about $200,000 of chasing a rainbow, which gets sabotaged by people which are stick in the mud and do not want to go with the latest 20 years of innovation.
I agree. I always tell clients that at the start of a meeting, if you are focused on first cost, the supply chain will dictate all the choices in your building. I can sit here and talk to you about radiant and triple glazing and all that stuff.
Yeah.
But if the supply chain coughs up rooftop units, then you've got unionized FM people. Forget it. Let's just stop this conversation now and select the rooftop units, right? And that is the North American market. Let's be honest.
Unfortunately, yes.
Yeah, that's right. And it's not going to change until the cost of hydronic systems and radiant systems and high performance glazing drops significantly, in my opinion.
You hit it on the head. I think as two Canadians and an English person or an English and American, we're not allowed to knock the Americans. But if you look at it, the way the American construction industry goes would be akin to the race to the moon. Right, we want to go to the moon, right? We want to go to the moon. But first of all, we're going to go to Mount Rainier because that's the highest mountain we've got on our side of the ocean. We're going to go there and see if we can land on the top of it, and then we decide whether we're going to go to the moon. It has no comparison whatsoever.
No,
right? It has none whatsoever. They probably did, actually. They probably went there with the people from, Studio City and done the whole mock-up. They haven't been to the moon. They were on top of this mountain in Washington. But you see what I'm saying? You've got the dichotomy of two opposite ends of where we want to be. This whole thing about innovation, about sustainability. I mean, that's why LEED is dying, because LEED has no numeric value.
LEED is over. I tell all my clients it's finished. It's a done deal.
It was good, and I think we mentioned this prior, that it's there very good, but it orchestrated that everybody could sit around the table and do their panel. We're fed up with all the stickers on the wall about we're going to do this and we're going to do recovery from this and we're going to do whatever, blah, 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 blah. Keep thinking, bearing in mind that the facility manager just wants a new rooftop unit.
Yeah.
Right? Keep thinking that all the time. Or you got don't want to knock all that. There's some good friends of mine which are in there, the well-being and all that. What does it actually mean to have LEED behind your name? What does it mean? Well, I managed to waste 6 months studying for something that's not going to be used.
Yeah.
But anyhow.
It's, I mean, ultimately, it's a marketing tool, and it did have a good role, but its time is over. But what's not clear is what is going to step in its place, right?
I think it's been there for years. And several discussions on some clandestine ASHRAE sites are, if this is nothing new to what we were doing with the oil crisis.
Yeah, thank you.
Was conserve energy of what we're doing. The only thing that comes there, and we have all this about net zero, a lot of people think they understand net zero or don't understand net zero. We want to get to net zero, which is carbon neutral, which is great, it's an idea. It's a goal. You will actually achieve it in some places, but you won't. But if you don't do anything, you're never ever going to achieve it. We're never ever going to decrease the carbon footprint or the carbon output of the buildings we use.
Correct.
You've got to have a goal to go in life. There has to be limitation. That's why we call it net zero. What is zero energy? When we have this whole thing about the EUI, Energy Use Index, and ASHRAE is sitting on the biggest thing, but they just don't have the market, the BEQ, which is the same as IE. Any building, what you should do would have a design goal of an EUI of 0.
Yeah, a performance-based goal. Right?
Very simple.
Yeah.
The only trouble, let's go back to the developers, not the developers, architects, or the people doing the building. If we're doing a building which is 200,000 square feet, 20,000 square meters or upwards, it has people in there. They produce energy. They require certain amounts of equipment. Like we've got computers, but they're all low, the screens are going down and the mainframes and whatever, blah, 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 LED lighting. But they're still in there, and they seem to forget this. So the easiest way to do a net zero building, and we've done one, the Pearl River in Guangzhou was the biggest net zero building in the world, 2.2 million square feet. Do you know why?
No people.
It was unoccupied. That was it. And they couldn't turn the PVs and the turbines off. But the trouble is, it was still churning away energy. It's a very facetious way of doing it. But the fact of the matter is, we don't want to do, again, the visitors, cabin up in Yellowstone Park can very easily be net zero. Absolutely not a problem. Is that going to change the world? I don't think so. You know,
when you can get Walmart outlets to net zero, that changes the world because of the scale, right?
Yeah, exactly.
Yeah.
Look at this again. If I'm allowed to say it, the ASHRAE High Performance magazine, it's got things in there which was, 20,000 square feet and 50,000 square feet and located here and located there. They never tell you again, back to the budget. What was the budget on this building, what we were doing, and how many people were in the building.
No.
Right? But I can tell you when we go offline, I'll tell you another story, but anyway, keep going.
Okay. So I agree with you, though. The whole thing is quite disingenuous, to be polite.
Yeah.
I do want to talk about your book, but before we do that, I do want to touch on very quickly on the COVID thing without triggering you too much. So when this whole thing started, I've done a lot of hospital work, and I always think about, typically, particularly in North America, recirculation systems, VAV systems, filtration that's not working properly, building pressurization, pressure regimes, that I'm the guy who brings that up at commissioning phase, and then everyone looks like, what? Yeah. So infection control is popular now. Let's say that, right? So did you see medical facilities and hospitals doing any retrofits to deal with pressure regime, to get some dedicated fresh air systems in there? Do you see that going down? Some UV in the air handling units?
Oh, yeah. Well, I know of them. So I have to be very, very careful to express myself. I've only been involved in a few hospital designs in the US.
Right.
Designing hospitals in the US, bear with me on this, is the easiest job in the world because it's OSHPD. You can just read a spreadsheet.
Yeah.
Room so-and-so, 4 air change, room so-and-so. And the reason being is that nice word, liability.
Yes.
Because if something happens, if I may, I designed hospitals for 16 years in Europe, right? And so I think I was weaned on them. The only unfortunate thing about hospitals and engineering is people could die in the place you engineered in the hospital.
Consequences.
Right? I don't see people that die in a big multi-story office building because a VAV unit fell out the roof or something like that. But what I'm trying to do is put it in perspective. When you start doing things of Center for Disease Controls, when you do disease controls, I try to remind my friends on this ETF and everything, the most sensitive place ever to do, if you ever do a burn center in a hospital, that is the most critical. Air movement is in there, temperature is in there, humidity is in there, everything is in there. Unfortunately, these people are also in there for a long period of time, when they're doing it. And if you do that, then you can talk and say, I'm an engineer, I can design a hospital. They got a pressure relationship of how much comes in there, we can't have outside air in there, the whole thing, right? So this whole thing comes along from this SARS thing, COVID-19 or whatever it is. The first thing that all the engineers have forgotten is, how does one, or how do we then assess that this can be in the atmosphere, whether it's in an aerosol or pathogen, let's not go there, if it's present, right? Simple answer is we can't. There are people much cleverer than us that are in there that can't do it. So then what you have to do is you have to do precautions in case the person next to you does have it and doesn't know it and transmit it, right? So we got this whole thing about putting this nose bag on your face, of going in there, of pressure. I was listening to this whole discussion about, we've got 1 inch thick HEPA filters. And as I wrote to them, that's about as good as a paper handkerchief is over a window, and this is what, let's get to it. And there's a whole difference. If you want to go to there, when you've got, in most hospitals, let's go back to our rooftop package units. We're probably going to get sued for this, but whatever, wake up and, see what's going on. And you've got this in there, and you've got, depending upon where you are, if you've got a high humid, you don't use much outside air because we've got to save energy and blah, 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 we do this. So it's all been skinned down. Back to these spreadsheets, which OSHPD have said what you've got to use, and therefore you've got a system which basically you wouldn't even run in your own home, right? It's as simple as that.
That's exactly how I feel.
Right. And this goes on. So you want to put something there. So let's walk the walk and talk the talk. So if you put air handling units in there, now what's happening is, and a friend of mine back to San Francisco, is looking at these hospitals and offices where they're trying to retrofit UVGI filters, and there's all stories about the UVGI filters. The biggest thing is that, not the filters, the lights, but I think they're onto an 8 to 12 month order now.
Right.
So if you order one, you're not going to get one. So that means, yeah, it's going to be great. You're going to get UVGI lights, but in the meantime, you're going to have 8 months of possible deaths on your hand.
Yeah.
Right. And then they've got to put filters in there. Well, we all know that in America, with the architects and whatever it is, and bless their heart, I know many of them, I hope I'm still going to get work from them, but basically their mechanical rooms are designed about the size of a matchbox to get the matchbox inside them. So you can't pull this, you can't put, a typical Haybar filter is, for me, 600 millimeters, 900 millimeters long. So, 3 foot, 4 foot, and then you've got to put the section in there. And then you've got to go for the other thing for the facilities people is, you got to check the pressure differential over it, and every 3 months, 6 months, or whatever it is, you've got to change the damn thing.
Yep.
Yeah, I mean, that's the cost, right?
Yeah, but we all know we're talking about these buildings which people want to go and reoccupy, and how do we know that the facilities people or whatever's done, basically it's the janitor that's coming in, hasn't looked at the filters in the last 10 years. What's the point of turning around and increasing the outside air?
This is the thing, right?
We just need to put both feet on the ground, right? Take a deep breath and just design the damn thing or get it to run the way it should be running.
Okay.
But if it wasn't built for that, we go back to square one again. Oh no, that's an overhead VAB, so-and-so. We got to pay you $35 a square foot, and we're not going to pay you a cent more. Right?
Yeah.
End of story.
Yeah, I mean, the running costs on HEPA filter systems are just immense in filters alone. And if you're retrofitting them, you've got to upgrade possibly the motor, rebalance the system, recondition the system, check the regimes, right? It's an ongoing cascade of work.
But let's go into the future now.
That's just the mechanical side. We still have a product that ultimately can be contaminated itself.
Yep.
And we have people not trained in dealing with contaminated filters.
Yeah.
So it's a big topic. It's not just about the air itself, the systems itself, but it's also the people maintaining it as well.
In this world at present, and let's do the whole world, we're not going to single out just America and other places, it's a litigious society, right?
Yes.
And what has not happened as yet is there are these reports floating around about the reoccupation of buildings after COVID, after the virus, right?
Yeah.
We have all these recommendations. If you look at them, the way it's done is it should have been written by, they should have had lawyers, attorneys looking at the text, because the text is written rather clumsy. So basically, in layman's terms, it says, if you follow these recommendations, the chance of transmission or something will be minimum 0 or whatever it is. Yeah?
Right.
Now, unfortunately, someone catches a virus within one of those buildings, under that regime, and passes away. Who do they sue? Because they're not just going to sit back and say, "Oh, that was tough shit." We knew he had a bad heart. We knew he had something. Who are they going to sue?
It goes up the chain, right? To the
it goes up the chain. The buck starts here. Someone's going to do it. Unfortunately, because this is a litigious society, what's going to happen now? We don't know yet, because fortunately, we're not there. Unfortunately, it's not going to happen. It shouldn't happen. But you see what's going to happen when people start turning around and say there's to each and every one, there's a loved one, and they passed away, they caught it, because your recommendations didn't stop or prevent the virus spreading.
Yeah.
And it's fool's gold. We are not intelligent enough to do that, to know what it is. And the basic thing lots of people are saying is stay at home and don't do this. But obviously, companies are losing money, or they want this. A different thing. Now, until there's a mechanism to actually test in spaces of all the things that I've seen, there's nothing there. People haven't turned around and said it's the same as what they've been doing in the airport. You go through Hong Kong airport, it's been going on for 5 years, 12 years, whatever it's going to be there, is screening people, looking at the temperature of their heads to turn around and say the first thing is, if your temperature is above this, you don't come in the building.
Yeah.
None of that, no. But we put bigger filters in and we'll increase the airflow and we do this. And the other thing is to get back where you were. Okay, so when you put these filters in, so there's so much fan power and you've got to pay for it, back to lead again. So you're going to put that price against a dead person.
Yeah, that's pretty much what you're talking about, right?
It is.
Yeah.
And if they can't afford to do that, they don't want to do that. They don't talk about anything. They just turn around to the people going in the building. Well, good luck today. Hope we don't catch anything. Right, let me know. Right. But that's what it comes down to.
That's a great mission statement, actually. You should put that on a sticker or something.
I'm sort of slightly worried about this now if it's going to be sent out. Yeah.
So, all right, I want to talk about your book, your second edition of your book, actually. So the book is a design guide for tall, super tall, and megatall buildings. Now, obviously, as an ex-property developer myself and chartered surveyor, tall buildings speak to me because I'm a megalomaniac. So tall buildings represent a lot of design challenges, right? I'm consulting on a project in Kuwait. It's Foster's building at the National Bank of Kuwait. I think it's 73 floors. I mean, that's the highest building I've ever sort of worked on. And I'm not really in the floor bit. I'm just sort of troubleshooting at the moment. But the challenges are immense, right? Just thinking about staircase pressurization testing, just as something I'm looking at the moment. You know, testing that's a whole. I'm writing a book about that at the moment because that's the red-headed stepchild no one owns, right? Who's responsible for that? But when you scale that up into, say, a megatall building, some of the stuff you see in China, I mean, how does that work? Actually, that's a big question. But, well, tell us about your new book. Why did you do a second edition? And what's it all about?
We done. The positive thing about the second edition was the first edition was sold out, so we had to do a reprint. So what we've done a reprint, and very within the 3 years when it originally started to when now it is, there have been so many developments in tall buildings. So it's like, let's start integrating those. I mean, a majority of them were not really the systems, not really central plants or decentral plants, you know, floor by floors or whatever. Was looking also at the climate. We've done a lot more with the climate with different people around the world, you know. And we wanted to get this in the hand of what is a design guide. A design guide is if someone's never done this building before or done such a building, what is there? What information do they need? You know, the Friday afternoon, their boss turns around and says, "Get me that report ready, or get me that data ready at 5 o'clock, and we're going away for the weekend. I want to read it through and do it." And you got straight, and you don't know what you're doing, right?
Yeah.
What do we do? So that's why we started looking at it, and where we looked a lot of it was on this infamous mythology around stack effect of buildings, and actually the Canadians, you know, Sean, Tamara, most of them came from smoke and smoke exhaust, and Milky and John Clote, you know, and all these people, they worked it out many years ago. Who's the other one? Bob Tamblin, another Canadian that had done all this work looking at it. So how do we sort of bring this together, or where do we look at it, or where do we tell people to look in ASHRAE fundamentals? You know, one of the things about the book is I didn't have to copy and paste from ASHRAE fundamentals book in there to make it 300 pages. Was okay, read it here, reference ASHRAE fundamentals, let's have a look at it. And it goes back to the old ASHRAE understanding of a tall building, which was very simply was 300 feet or 100 meters. Anything taller than that was a tall building. This day and age, well, you know, so the tall building is 100 meters, super tall is 300 plus, and mega tall is 600 plus, right? And if you start looking around I think that we got here, and I'm actually looking in here. There are where are we going? 765 buildings which are taller than 200 meters, which isn't the 600 meters. But when you start looking, just to give you some volume of that, the number of buildings where we are, it's phenomenal. These there was I forget there were here we go. I got here 148 proposed buildings more than 300 meters, and there were 7 buildings proposed with a height of more than 600 meters. That's proposed now, other than the number of buildings which have already been built, 10 or 12. So it's not just a fad. I've seen things that have just recently come over from China where they're going to limit they say they're going to limit to 500 meters, but you can have exceptions. But the trouble is, there's sort of a quest, rather like the 100 meters. There's always got to be the fastest in the world. Yes. The first and the fastest. So we do this. When we look back, I mean, what were we, America, Empire State Building, Chrysler Building, different buildings, right? Then we had the Twin Towers, right? That were going. Then I guess Petronas was coming along, right? And then start moving around the world of what other towers there are. I mean, obviously, the big one is the Burj, 867, and the other one coming along now is the Kingdom Tower, which when it gets back under it's only partially under construction now. It's still 300 meters. It's got another 700 meters to go. It's going to be 1 kilometer high.
I flew by that a few months ago.
Yeah, why? Because it's there. Yeah. Because do it. So to come back to different things, when we start looking at, we were talking about stairwell pressurization, or we were looking at stairwells and different things. It's not just a question. A lot of people have turned around. I think I put it in the book there and said it. A tall building isn't just one floor multiplied by 150, 160 floors. It's lots of other things of how they all talk to each other and what you do. So when we start looking at these buildings, so if you're doing a building and you're serving a client, mostly an architect or the owner, occupied, developer, or what it is, and they want to know about it, how do you come up and professionally explain what the problems are of a tall building, or mega tall building, super tall building? And that's basically what we tried to put in the book. Yeah. And how do you orchestrate it all together? There's no, well, a lot of the work that we've just been doing now on stack effect, on climate conditions. The climate changes as you go up. Yes. Yeah. Which isn't a problem. Delhi in the winter is the design temperature in Delhi is 6 degrees Celsius. But you start going up the building, it gets near freezing. So would someone think about the fact is that they might have to have a heating system, but you might have to put glycol in there or something like that because you're under the freeze point? Yeah, exactly, right. It's simple, and I don't advocate glycol or whatever it is, but I'm just trying to design consideration, right? The different things. So when you do a tall building and you go up and the temperature drops down, you do your load calculation, it's a plus because the load calculation, the cooling load calculation is less because the outside temperature. Do it in the winter, it increases. To go back to, we were talking before, the jobs in Moscow, you start off at minus 25 degrees at zero. When you get to the top of the building, you're up more than minus 32 degrees. Yeah. That's a big heating load. And we all know, let's go back to Canada where you guys are. The biggest problem with any tall building or any building up in Canada, anything, is Monday morning heat up, Monday morning warm up. Yeah. Right? Insufficient capacity in the system. Well, if you haven't taking into account the temperature differential at different heights of the building, you're never going to get it there because your system's always going to be undersized. Yeah, so this is the old Welshman diversity as well, right? You're trying to design for an optimum diversity. Oh, the diversity of the building, that's something completely different. That's a PhD thesis these days. If you talk from, you know what's ruined diversity in buildings? And this is going to get us sued. Is WeWork. Because WeWork turns around and says, you go to any office and you can work on a postage stamp, right? That's your thing. Off you go on the postage stamp. So if you look then, being facetious, instead of one person for 10 square meters, we're talking one person for 6 square meters. How many people do you have in your building, right? Yeah, exactly. Loads going through the roof, right? Right, and there's a couple of things. Then you go and speak to the guy designing the elevator. So you say, well, how are we going to get all these millions of people at the top of the building or through the building? Oh, no, we didn't design that. We designed to this. So you get another number. And then you get Mr. Sobriety called the fire marshal and turned around and said, how many people are you going to allow in that building? Well, he turns around. So therefore, that's your diversity. So if you were to do it at one person for 6 square meters, one at 10 square meters, you get nearly a 50% diversity from that number, right? So you will get floors which are intense, but you'll get floors which are less intense. you know.
That's a really interesting point, actually, in terms of a sort of recent social phenomenon, like the co-working space, packing people in pre-COVID, you know, WeWork, that whole phenomenon, because that's not a solitary business model. There are other business models just like that, right?
Yeah, I think that was a short-term fashion. COVID has killed that off.
Yes, agreed.
You look at WeWork now. They got this building over in the Netherlands called the Edge. And they say that it's, you know, here we go. Robert's going to start laughing now, but it's the most intelligent building in the world.
Yeah, I've heard that one.
Right? And have you seen anything about this building? And
I've heard about it. I've yet to meet anyone who can talk in detail about it.
Well, yeah, well, let's talk about 2 minutes in detail about it. I mean, it's the pretext has been there for 20 years, 30 years. The only thing that wasn't there, really. I mean, one of the greatest books to read about building engineering and building controls is The Third Wave by Alvin Toffler. Now, shit, if I can remember that, when would that book come out? Only because he was turning around saying we would work at home and there was different things that the actual, the intelligence in your microwave oven could be used to operate your heating or cooling system, right? We've got this. So now we've all got these magic things called, I'm not allowed to talk about things, mobile phones, right? Yeah. And what it is basically you have a number you can call up on your mobile phone, and you can turn around and say that I need a place to work, and it says, okay, you've got seat 53A or whatever it is, and it gives you the chance then to say, I would like the temperature at 21 degrees, right? Here endeth the sermon, because you can tell that. What it doesn't tell you then is how the building can actually maintain 21 degrees. We know how it can maintain 21 degrees with temperature sensor. We can do that. That's the easy part of engineering, right? Yeah. But how's that system, because it's probably, and I do believe it's an overhead VAV system, actually going to direct it down to that space that we work? Now, you could have Joe Blow next to you that's already been in there and says, no, I want it at 24 degrees. And next to you could, I'm careful of the name, another that says, I want it 18 degrees. Now, you tell me how that works, right?
No, it doesn't.
It does. It's a con. It's a myth. However, it's been sold. It's splashed around halfway around the world now, and everyone's looking at this. Let's go into this building. Now, let's go back to another thing.
Sorry, we call that Never Land buildings. Peter Pan designed it.
Yeah. Well, no, but there's good and bad in everything. What we start off our discussion with saying, I never say that again, would there? No, never tell people that. And so we were talking about net zero energy, weren't we?
Yeah.
Now, how do you control the energy in the building where, let's throw a number out there, 5,000 of its occupants can choose what temperature that building is going to run at?
You can't. It's a mess, right?
Well, you could do, but would that be an optimal now? I mean, ASHRAE 90.1, whichever we want to say, ASHRAE 90.1 is the go all, do all, be all around the world of about energy conservation in buildings. I mean, it's done for design, and that's what it is. And when you look at this big thing we do with this joke and how much you comply with ASHRAE 90.1, so let's take ASHRAE 90.1 and let's take the Edge building next to each other. So ASHRAE 90.1 said you're going to do this, and do everything like that. And then you give 5,000 people individual controls over the HVAC system. Now you tell me which is going to consume the least amount of energy. Right? Because does it turn around to them and say, oh, Mr. A another, you wanted 22 degrees or 21 degrees at your bases. So we were doing an optimal of 23 degrees. So for the extra 2 degrees, we're now going to bill you another $2 per hour of sitting at your desk to pay for the chiller energy.
Yeah. God, yeah, I mean,
well, the whole concept reminds me, what was the bridge? It was in Tacoma, where the wind created a certain harmonics in the bridge or something. The bridge just and the bridge just exploded.
Yeah, well, Foster's done one across the Thames only about 20 years ago, and that nearly exploded, didn't it?
I was working for Eric when that was going on. That was interesting, watching that news piece. Foster's basically threw the Arab structural engineer under the bus on 6 o'clock news in the evening. It's hilarious.
But there's the world of make-believe where people think you can actually control a building with 5,000 different people controlling the controls. Yeah. And then there's reality. And the two don't mix. Like it's not practical to have that many people thinking that they can
Right.
have their space conditioned the way they want.
Because buildings are about marketing. Adam, the CEO of WeWork, was the marketing guy. His whole thing was the unicorn. Oh, we're a tech company. We're not just reselling leases. We're a tech company. And part of the bullshit was, come in and here's the temperature at your desk. It's marketing, right?
It is. And there's this whole thing about, I was reading something recently as well, again, personal controls and everything. So in the real world, well, we are not Berkeley, but in the real world, unfortunately, there's also this other thing. I've said it before, and I'll say it again. America is based on America. America is the cheapest country in the world for construction. And people say, why? We got all these great offices. How can you have a valued engineering phase before the construction documents are finished? So you get these goonies that come in, they've got an MBA from Blip University, and they come in, they say, oh, we're going to save you this much, we're going to save you this much, we'll save you all this money. All they're doing really, they're not saving anything, they're taking items out of it by saying, and then we go back in history again, because we can remember the history. We've all got grey hairs, right? Most of us have, Adam. Yeah. And you turn around and say, well, on my last jobs, because I haven't changed how I do things for the last 15 years, we've only had one temperature sensor for 6 offices and one VAV box for 6 offices. So what do we need individual controls for? I can save you so much. There's $200,000 here, and there's this much here, and there's this much here, blah, blah, blah. Save money. Everyone says, yeah. So what's the point of touting a building, of being intelligent, or starting of being innovative with the building, when you bring it back to prehistoric mathematics?
Yeah.
In the design before he gets at it, then everyone's backs up against the wall because the client turns around and says, hey, where's everything that I wanted? I wanted this and that. Well, remember that money we saved you? Yeah, well, we took the money out, you had the money, so there's no way. How much is it going to cost? Well, it's going to cost you 3 times as much now to put it back in, so you haven't really saved any money, right? And the best one I hear, and
yep,
I still have to live with this, is if you're doing a speculative office building, and again, let's talk up 500,000 square feet, not just something substantial, and they're doing the lease agreements. People are fighting now. So I think we all know, industry accepts that LED lighting is here to stay. LED lighting consumes the least amount of energy, right? So if you're doing a tenant fit out and the lighting is in the tenant spec, you cannot spec an LED lighting only in certain circumstances, because you're putting an extra cost on those tenants to do their fit out. And it's bullshit. Everybody should sign up for the same thing and say, you can choose anything you like as long as it's LED. What's the point of designing for 0.4 watts a square foot or 4 watts a square meter and then having 12 watts a square meter installed? What is the point?
No, that's a weak landlord that does that, I can tell you that.
No, it's not. It's commonplace. Unfortunately, it's 80-90% of all buildings going. And then the other one is, well, we've got these high lights in there, so let's put occupancy sensors in. Well, it's do the same as the thermostats. We've now got one thermostat for 6 offices, so we'll put one occupancy sensor in for 6 thermostats. But what we will throw in is one, light dimmer for 6 offices. Back to square one.
Yeah.
And then we get the Berkeleyites in there with their Birkenstocks and their woolen socks again, turning around post-occupancy evaluation. The design engineers were decrepit. They didn't know what they were doing. They should never be on this earth.
Yeah. That's retrospective engineering, right? I got a degree in that. It's called commissioning.
Yeah.
The Edifice complex will continue in just a moment.
Robert, are we there yet? I'm bored.
I know it's hard to believe, but the future has finally arrived in Canada.
How's that then?
Well, smart remote building and equipment management is now available from Sensor Suite.
Go on.
Sensor Suite? Yep. They're an innovator in smart building technology. We like them. They can monitor, control, and optimize anything in your building, saving you time and energy.
You mean Sensor Suite are moving Canadian buildings into the 21st century?
Yeah, I know, another hard thing to believe, but they're doing it, and they're saving owners money with efficiency gains.
Okay, I'm in. How do I find out more?
Got to go to sensorsuite.com or call 1-855-773-6767, and also check out the July 2020 episode of the Edifice Complex podcast and listen to Sensor Suite CEO Glenn Spry.
And now, back to the show.
I'm a big fan of, I sort of study economics passively. I like the economic phenomenon of the skyscraper curse, right? So the skyscraper marks, wherever you see the tallest building announced, you should immediately short that place, right? Like Empire State Building preceded the Depression, right?
Yeah.
Petronas Towers in Malaysia preceded the 1907 crash over there.
Yeah.
The Dubai one preceded 2007 crash. So at the moment, all the towers are in Asia, I guess, right? I mean, those stats you were talking about earlier, I guess the majority of them were in Asia.
Yeah, most of Asia and Middle East.
Yeah.
Most where the money is, and
yeah.
I said it before. It's rather like the 100 meters race. You know, who wants to be first? And there's always going to be something in there. There is a logic. If you actually look, anything. If you want to really look at the numbers, the number of sensible and occupied buildings or buildings that work are around about 400 meters. Right. That if you go around the world, you look at the ICC in Hong Kong and IFC, and you look at things. I mean, I don't know out of my head, but I think that what's the Freedom Tower, isn't it, in New York? That's 400 something. Petronas is 400. I don't know all these numbers out of my head, but I'm just saying that's where the commonplace is. There are quite a few 600 meters there, and then it gets on to where we're going to go. The main things when you look at these buildings, right? So they're not 600 meters of offices. The offices is a small part. The offices is the first 1/3. A majority then is residential, and the top part are now 5, 6, 7-star hotels.
Yeah,
that's what they get there. You know, and you did mention before about this thing about the pressure differential that goes on into the elevator shaft. You know, the thing is, so when you get and this is what the Kingdom Tower in Saudi is very well engineered, and if I may just slightly breach upon it from what I know from the project, it's rather like a submarine because it's residential. So what happens is that when you're paying all this money, different things, and there was a certain architectural design where they decided they could have a balcony on the place and whatever, you know, it's something different, you know. So what then happens is if you have the outside door open and the inside door to the corridor open, a light goes off if it's open for more than 20 seconds or something like this, because they have to signal it for the whole balance.
Yeah.
Now, the building's 1,000 meters tall. I don't know how much it is. I think my good friends at ESD can tell me exactly.
Kilometre. That's its selling point.
Yeah, but what the residential portion of it is.
Oh, right, yeah.
So you've got over that residential portion, you've got any number of exterior openings could be open at that time. And then we get talking about the guys that done, you know, the wind analysis and the temperature analysis. It could be any number of wind pressure on the outside or temperature or whatever. And so it's, in American terms, it's a turkey shoot. What the hell's going to happen on there? So then you have to balance that system out or start looking at what's going to happen in there, you know. And it's being paid for, or it would be paid for. So you got to look at how it functions. So if you have 2 doors open, they can't be open for longer than this. They got to be closed, and then you got hermetically seal the whole place up, so you can bring it back to a neutral manner, or whatever happens. Then is fire. Should there be, unfortunately, a fire within the space, how do you stop that fire spreading?
Yeah.
The only ways of egress are through the building. So
you're creating sort of buildings within buildings, right? Layers within layers. Is the only way you can handle it.
The compartmentalization engineering is really critical in these structures.
Yeah. Weren't we talking about hospitals before? About the pressure relationship? It's no more of the pressure relationship in there. But it, you know, the unfortunate thing when you look at these big buildings, if someone that were to then, you take a quantity surveyor and you go through the building and say, well, this is a bit no, and look how much we're paying for controls. We're paying for 3 times as many controls on this building. Well, yeah, duh, because we got 3 times as much of control. We mentioned value engineering, didn't we? It comes Hobble on Cassidy again. I can save you so much money on the last building I'd done, but it was only 17 stories, but we can take all this out and take all that out. You know what I mean? So you got to pay it.
And that's the problem in that part of the world. Most procurement is design and build, right? So they take the design to 40% or DD, and then they hand it over to a design build contract. So I'm not sure if the Kingdom Tower's in that game because it's started off by the right?
I don't even want to go there. But, well, to be very honest, I don't know. I have heard that it's under construction again, but there are many different things to be there. I mean, the Burj was also, going through. I mean, the construction time is phenomenal. When you look at when we're working on Petronas, I mean, it was astronomical how long that takes.
Yeah, no, it's a massive undertaking. One question I have is, I've got mixed feelings about sort of high-rise buildings from a sustainability point of view. So, you can argue there's sustainability because you've got a small footprint and you've got a lot of people there.
Yeah.
But can a high-rise building, say a 400-meter high plus building, be sustainable by any definition?
I don't. I'm not going to talk about sustainability because I don't think it's in there. I would talk about, can it consume the least amount of energy for the function it provides?
So on a performance basis, right? On
a
benchmarking basis.
EYB could, and we did put that in the book, in the previous one, and we've updated that now. I mean, if you look at it, in America, I believe there are 17 cities, there might even be more now, that request that all the landlords provide their utility bills so you can work out what the EUI is of this, so it's dynamic when you look at it. So like I say, the EUI of a building could be and should be zero, right? So it doesn't matter how much, of the pretty stuff you put on the side, PVs and wind and whatever you do. I mean, I think this day and age where everything's going electrical, there's a big rise in heat pumps. As soon as you do a heat pump, it's an electrical heat pump, you're up there. I don't want to talk sustainability because it still does it. What we fail to identify is the sheer size of a building, right? If we're talking a 400-meter building or something like that, and you're comparing it with a 300 or 200 or even a 100-meter building, how many people are in there? What's the function? What we're doing, right? Yeah. I mean, if you go to, I haven't read much recently, but the One Bryant Park in New York, right. Which is a Bank of America building. I don't think we're going to get sued for saying that. Anyhow, a reporter went in there, and I'll say it in a way, and was asking around about all the different things to the building, and he came out, and the EUI, and there are papers written on this, was about 3 times more than what a normal building should be for that magnitude. And they tried to blame it on the trading floors. Even if you have a building of so many floors, you're not going to have 20 or 30 trading floors. You're not going to do it. You're going to do it. But there was something fundamental. How did that building get a LEED Platinum? By consuming that amount of energy. And if you look at it, the building's still there, but it's all white from the face of the earth. And I mean, I've seen the papers and the reports on it, and they're very realistic, But I think what people were forgetting was, let's go back there. Instead of reporting all that, how many people did they have in the building? They might have been moving another building around and putting twice as many people in there, or what were they doing, or how many people? It's the whole thing. I mean, we're talking about occupancy on a building. How many people you've got in there? There's all these different things. Everyone's got these magical tie cards, or like a credit card thing you can put on there. They know exactly, but apparently we're not allowed to do that now because that's an infringement of a personal space. You can't do it. But don't you think that should there be a calamity in the building, the fire marshal would really like to know how many people we got inside that building or not?
That'd be useful.
Yeah. And you talk about these smart building interfaces. If you had all that information, and they do gather this, you would turn and say, do we need that extra chiller on today? Do we need that extra boiler on today? Can we do this? How much fresh air do we need? Or what you could do is start optimizing the system. Why are we using this much fresh air if we've only got this many people in the building?
Oh, you're talking my language here. I'm doing a lot of thinking recently on IoT, and I've got this sort of theory that design in the future will be evidence-based, based on real-time measurement. You know, if the cost to monitor in real time falls down to cents on the dollar, takes the VE argument out, right? Say you can just plaster these places with 10-cent sensors that can connect to 5G, which will be the building will be a 5G node, and you can just harvest all this data. Then you start getting real information for control, real-time control. You could do control fresh air on CO2. You could control it in different ways, right? In real time. You could be specific, but also you can get this wad of design data. Like, what does an office building really do? Boom, right? You could sell that data, but then everyone's going to get the ASHRAE guide out and go, "I've got to do this so I don't get sued," right?
Exactly, and that's. I mean that you mentioned two good things. Let me go on the other one. When it comes around, you mentioned about something I just forgot now. Let's start with the other one, and then it will come back. This is age. This is experience for you. You only remember so much, right? When it comes in, we had a good discussion on the building sim website there about different people. What do you actually put on there when you do your should you submit an energy simulation for building? How accurate is it? Right? And this is what the biggest thing that's coming off about all these simulation jockeys. Really, within America, we know about the PE, we know who is going to be responsible for it. It should be part of it. See, in California, it is. The Title 24 is part of the actual bid document. It's on there, and it should be around it. What would then start happening within the society then, if people were sued for not making the promises they've calculated? See, in Europe, that's why it does it, because they have a different way of doing it. Their legal system is somewhat different, or it can be mandated as a federal thing, is like Germany, Sweden, the Netherlands, some ways England. It turns around, you turn around and say, this building is not going to consume more than this amount of energy. Done. You know, America does it with 90.1, which is a great tool, and say we're not going to consume more of this amount of energy. However, don't turn the building on. Do not occupy the building, because it's only, it's only based upon these assumptions.
My point is, when I was speaking at the last commission conference, every energy model makes an assumption that every VAV system is perfectly sized, perfectly working, perfectly set up, with optimum set points working. Right?
Yeah.
And in 39 years, I don't think I've ever seen that once.
No. Well, I will be very careful with what I say about commissioning things. I actually think that the way it used to be done in the Netherlands, and I'm sorry, I was there for 16 years, so I know about it, was the consulting engineer, let's say, commissioned the building and done everything based upon what the consultant engineer had designed and what was in there. So the person who's done the commissioning was the contractor, so it showed the consulting engineer that it met the spec, and the consulting engineer signed off on it and then handed that to the client, because that was what was designed.
Yeah, perfect. Right? That makes perfect sense.
And that makes sense. I mean, no disrespect to commissioning engineers, bless their heart. I mean, if they really want to be good engineers, Adam, they would have been. But the number of times I come around, an engineer says straight away to the client, and tell me, I'm going to get this building working for you like that. Well, I'm going to swear in a minute and say, naff off. When we start with a building, we've got a blank piece of paper and a budget, which is mostly unknown. And you start designing it. It's very easy, going back to my Berkeleyite friends and their woolen socks and Birkenstocks coming around and saying, oh yeah, you've done this wrong, you've done that wrong. Now, hang on. The reason we've done that was because we had to save so much money here because we wanted extra bathroom fit-ins. And that other thing, we didn't get those controls because they wanted the marble in the lobby.
Yeah.
Right?
Yeah.
The other thing is because the top 10 floors were going to be, to AJ Flippy or something, and they wanted this in there, so we had to put the extra. It's business. And that's also one of the big things that's missing, and I will knock at ASHRAE now, is ASHRAE thinks they have so many business people, but they are totally aloof of the business of consulting and contracting in the USA, where a majority of their members are.
Yes, I couldn't agree more with that.
And that unfortunately is in there. You know, we've got all these people with these names and numbers and bits and pieces, but at the end of the day, they know shit diddle about whatever happened. And the reason we do it is, we talked about it at the start of this, is you got to get your bloody nose. You've got to find out something that goes wrong. I thought we paint a very dismal picture now, but you've got to go out there. But at the same time, you still got to be innovative, and you've got to provide people what you think, because that's what you're a consultant.
Yeah. But in defense of ASHRAE, there are there are a number of individuals within the organization that doesn't apply to, Peter. And so, you know, and you know who they are, and I know who they are. I mean, these are people who are practitioners. They've worked a long time. They understand the economics of development, and they understand all the consequences. But in any organization, you're also going to have people coming in that don't have that experience, and that's what gives it its diversity. It's not always great, but there is some good stuff there, right?
Let me agree with you in quantifying one. I agree. I've met with ASHRAE some phenomenal people and learned some fantastic things. And one of the things that was always there, and I will say that in the past tense, is you could go up to people and you could say, hey, I'm having a problem with this, or so-and-so, didn't you do so-and-so and so with this? Right? I can mention names, so I won't mention names now. People turn and said, let me call you back in so-and-so days, or what's your email now? And you get something that helps you out, which is tremendous. Yeah, right? Yeah. One of my thing about ASHRAE is ASHRAE does not market that.
Yeah, you're right. Yeah.
It just keeps it under one thing. We're ASHRAE, we're going around now, we're doing this and we're doing that. ASHRAE's never turned around and looked at the people who are the real fellows of ASHRAE, the real people that have been around it. And they might be one-man shows, they might work for big companies, they might do anything. They're all in there that have done something really good for the society of engineering, HVAC engineering, right?
Yeah.
And that is unfortunate they don't do it. If you have structure, look at AIA, how it goes. AIA is every year, they do different things, they have all different things to support their members, to promote their members.
Yeah.
ASHRAE doesn't. Look at this new headquarters building. It's a joke. It's a joke. It's a 20-year-old catastrophe being designed, right? And the trouble is, why should we worry about it? We shouldn't. It should just be a headquarters, a space. It could be a tent in the middle of Peachtree City, as far as I'm concerned, but people work. But the trouble is, you know, we're going off on a tangent now. But anyhow, I think, practice what you preach was what our people done, and make it work and get it work for how people are going to be there. I'd love to see the Berkeleyites go into the new ASHRAE headquarters and come out with a post-occupancy evaluation. Yeah, it will bring tears to your eyes. Yeah.
Well, maybe we'll see what happens. I'll reserve my thoughts on that, because there's some, again, in defense, there's some good people on the design committee for that.
That. Oh yeah.
But you're right. I mean, like when I think about guys like Bill Code, who passed away a few years ago, there was a guy that, I mean, he was a walking library of knowledge and practical knowledge, But he was a good, solid guy. He was easy to get along with. You could ask him anything. He was happy to share all the war stories, that he had gone through. But we have actually lost that. You don't see the Bill Codes walking down the hallways anymore that we used to see. That's true.
I don't think we want to go where this conversation could go, and it would be extremely good. Because
we'll take it offline.
But I agree wholeheartedly with you, and that's what's missing, because I believe that ASHRAE is the only society that we have in the US for HVAC engineers that should be actually supporting HVAC engineers. One thing that I'm just going to mention now on a small thing, then I think we need to stop because we're getting too close to the bone is, if we have a society where there's 57,000 members, I know they're all around the world, but the majority of them are in what they say is international, so the USA and Canada, wouldn't you think they could arrange for a liability insurance for all of its members, a reduced rate?
That's a lot of buying power.
when you're talking about different things, I'm not talking about a healthcare plan, what people do, but when you're out there being innovative, you're putting your head on the chopping block every day, simple things like that. So therefore, it comes around. I'm going to stop it now. I'm going to say that's how much faith that the ASHRAE leadership has in its members. Here ended.
Okay, we'll have a part 3 to this.
Because I see what you're saying, though, but the buying power thing, that would be a logical thing to do, right?
When you go there, so you call the insurance company out, so I want to get insured. Oh yeah, great. I mean, how many people you got? 57,000. I'll get back to you.
Yeah, exactly.
And it helps everybody up. They don't have to do it. I don't get it. I do get it because it's too much trouble.
Yeah.
But anyhow, let's go. Talk about tall buildings.
Let's go back to your book. So I'm very gratified to hear that your book sold out, because there's not many definitive books on how to do this. There's books about tall buildings. Yeah, it's all about how great they look and how tall they are, but not about the engineering. And I'm really pleased that it's necessitating a second edition. Yeah. So, what do you think? If I was a journalist, I said to you, so what's the current state of the art? What's the 400-meter building, right, is what we're talking about here, at least. What's the current state of the art? What sort of systems are we going to see in these buildings?
Well, the first easy question as a cop-out is one that meets the client's needs. What is the client? But see, this is where, again, another caveat is you always have various clients, because you're not a single client in a building. Those days are gone. So you've got multi. So therefore, first of all, it has to be flexible enough to be leasable to various clients, and who they're going to be and what they're going to be. I feel then on the bottom side of that, then we need a system. There's no cut and dried system, A, B, C, D. Yeah. However, the energy consumed in providing that space conditions for those leases should be the least amount possible, right? That should be in there, the least amount. That's where we come from, and it should be part of it. Where I think that at different times that to be competitive, that people need to start, especially the lease operators, to start saying, well, come and lease my space, because you're paying 20 cents less the square foot, because we're that much more efficient. We're consuming to make a statement. We're not providing that many, that much CO2, carbon to the atmosphere. So I think that's in there. The other thing is, and Robert and I we're gonna get onto our preach now is what needs to become about the whole thing is this whole thing about occupant comfort. How comfortable? I mean, I believe there's two big reasons why companies actually change leases in buildings. One of them that's been going on for years is the accessibility, the amount of elevators, where I go up and where I go down, or what. But I mean, that's a fixed thing which is inside the building. The other big one that's out there is thermal comfort. However, the knowledge, if I may, the understanding that Robert and I have over thermal comfort is a great deal different than a majority of other people have of thermal comfort. And I think I can go on record as saying is that look at that high performance magazine that comes out in ASHRAE. Oh, it met thermal comfort. What they say is the temperature is going to be between 21 and 24 degrees. And that, they say, is thermal comfort. Well, we know there's more than that. Yeah. So we want to help the architect.
I think Robert's going to get triggered in a minute if you carry on.
Well, yeah.
But he's right. Absolutely, he's right. And we see that all the time. There's an illiteracy within the community that's rampant. People just do not understand what thermal comfort is all about. Anyways, keep going, Peter.
But they do. I got to correct you there. They do. When it goes wrong, when people get uncomfortable, but then the uncomfortable part is, so why are you comfortable? Well, I don't know. Are you too hot? Are you too cold? So here's the point. Let's go back to building and business. When you're doing the 200,000 square foot building out and so many $1 million, shouldn't you at least look at what the conditions are going to be within that space? And look at it. Robert and I are working on an article now for ASHRAE Journal about what design engineers can do to evaluate, to see whether the conditions are going to be comfortable or not. not just put the system out there because the facility manager wanted an overhead VAV because the other 3 buildings have got an overhead VAV. Well, the other 3 buildings could be uncomfortable as well, right? And where the non-quantitative substance is, that after all these years, it's still got the wrong name of improving productivity, which we know needs to be done, right? Because what is productivity? Somehow or other, we need to do some research work or development work on what is actually the financial incentives of having less sick time and less breakdown time, not productivity. It's not when the old word they used, productivity, with a couple of people that were very good. It's not going to be, this is thermal comfort, so the productivity is going to increase by 5%. Not everybody's going to work harder for 5%. That's productivity. What's going to be there is when companies and leases start looking at what they pay for their occupants in salaries per year, and then look at them, because what you want is everyone wants them at their work table working as much as possible and not goofing off because it's too hot or too cold. And you talk to any facilities managers, how many reports they have on a Monday morning. Oh, it's too hot, it's too cold, it's too drafty, or whatever it is, and the person next to them says nothing.
Yeah.
And that, unfortunately, is that all needs to be brought together. We've got it, we know it, it needs to be brought together, and we need some research, we need some good data to tell people what to do. And until thermal comfort gets quantified in that manner, then we might as well just kiss it goodbye and go back to say it's 22 degrees plus or minus, suck it and see.
Yeah.
So what you're advocating for, a data-based decision making, right? Which is
right.
Perfect.
Yeah. Now I knew what I forgot.
Yeah.
Artificial neural networks. Can you remember those? There was a guy called Ron Nelson from 25, 30 years ago. There was another great guy, Pete Brothers from Johnson Controls. He's back in New Zealand now, if he's still around. Kay Nestler's still at Johnson. Mimic the man. We're going to have an artificial neural network in a control system in a building which will follow a person's brain things, right? So think like a person, all this, like, whatever. When you're in England, did you ever see the Beano with the numbskulls? Running around? That's an artificial neural network, right? Now, you go to your local controls guy, rep, and you ask him, say, I want this WXYZ controller or so-and-so, but it's got to be artificial neural network compatible. It's got to be said to go, what? What's going on? What? It's BACnet, it does this, it does that. No, it's got to be able to think like a person, because that's what's doing it.
The Edifice Complex will continue in just a moment.
Adam, it's time to thank some people who are on our side. Blue Rhythm commissioning software.
Blue Rhythm is the commissioning software I've been looking for. Most projects I consult on suffer from poor information and document management. Frankly, it's just chaos out there. Blue Rhythm removes this chaos. It is a secure, always available cloud solution designed to work on any computer, tablet, or smartphone. Their Android and iOS apps allow seamless transition between online and offline work. But what I like most about Blue Rhythm is their painless and fast onboarding process. Our team will bring all your existing forms and checklists into Blue Rhythm for you, or you can use or adapt their pre-built, pre-functional and functional performance test sheet templates. But it's more than that. It enables collaboration, automation, and easy planning and project management for all your projects. Blue Rhythm provides amazing support from a team that really understands your industry. To find out more, go to bluerhythm.com or call country code +1 612 460 8305. Also, you can hear from Blue Rhythm President Andy Martin on episode 26 of the Edifice Complex podcast.
And now, back to the show.
My personal theory is, with the rise of 5G and fast internet with minimal lag and the continuing falling cost to monitor things, at some point it's going to be disruptive to the building. How we live in buildings, how we control them, and how we design them.
It will. But another point we discussed, I think prior to this, when we were talking about how we present a different scheme, right?
Yes.
How we present. So, we've got the money people on one side, and we've got the people that are going to go in there, developers or whatever, and architects. You imagine telling them that we're going to have these artificial neural networks, which are like lots of little people running around in your brain telling you how to operate the control system. Yeah. I mean, that's going to be a major sales point, that is, isn't it?
Yeah, that could be the death of your sales career.
Would you like to explain that before? Well, let me get this comic from the mid-'60s in England, and I'll show you what. But that's an artificial. But the point is, unless people can accept that, can be presented, and can we accept it, we're never ever going to move on.
No, there's a marketing deficiency and sales deficiency in our business, really. That I don't know how you bridge that, like a storytelling, or other industries are great at selling average shit, right?
Yeah.
Let's face it, a 400-meter tall building is an awesome thing. It's like defies so many things, right? And yet we don't sell it well. We don't describe it well. We don't pitch it well. People don't understand how hard these things are to do, right?
Again, I'm going to have another dig at ASHRAE, because ASHRAE turn around and say, how you can present yourself, how you can do different things. Let me tell you another little story now. Let me digress. So we're doing a lecture. We've got all these engineers, might be some architects in there, right? And you turn around and say, right, okay, so can I ask you, without being commercial, what sort of cars, automobiles you got? How many people got BMWs? And you get people put their hands up. How many people got a Lexus? Got this. How about Mercedes? Got this and got everything. All right. So we got all a good mixed match of cars and everything. So when that car wants to service, the automobile wants to service, I want you to take it down to the local fire station. I want you to park it out front and throw the keys in there and say, change the oils, check the tires, and have a look at everything. By this time, everyone's looking at me like they know I am. I'm completely insane, right? I say, do you know what the whole point of that is? When you build a building of so many million and you do everything, why do you give the keys to run the building to the janitor? Right? Why do you give the running of that building to the janitor? Bless his heart. He's more interested in getting off early, right? Keeping the car park clean, getting graffiti off the walls, and making sure all the toilets aren't stopped. And then you turn around to him and say, by the way, we've got radiant panels in the classroom. Oh, shit. Right. What's going to happen here?
Yeah.
Right?
Absolutely.
And you talked about Bangkok Airport. We've talked about that. We get complaints about Bangkok Airport. The radiant floor isn't working. And I will go on record of telling you what happens now is. So what they found out is when you look at the airport where the concourse is, the concourse then, for American things, is on the second level. So the first level, which is the tarmac, which is out there, that's where all the airport secondary systems are, like catering, lost luggage and everything. So many of those companies, unfortunately, over the years in Bangkok Airport, are no longer there. I'm not going to say they're broke, they're no longer there. So what is the temperature now underneath the floor? It's not at 24 degrees, which it should have been because the space should have been conditioned. It's 32 degrees and like 80% humidity, right?
Right.
So if you've got a radiant floor running at 16, 17%, you've got this thing called humidity, haven't you? Right? So to prevent humidity, do you know what the maintenance people do? They shut off the whole field. And if you looked at the size of the radiant floors on Bangkok and what the zones are, these are actually in the magnitude of football field sizes.
So they're just shutting the cooling off.
So they shut the cooling off to stop the condensation under the floor, and then they wonder why it's getting hot in the space.
Wow. That's
right?
Good.
And that is a perfect example in this case of facilities people, only because they wanted to save money where people come from one to the other. And they don't want to go back to basics because they just look at it as a facilities job and nothing else.
Yeah. There's been a de-skilling, or there needs to be an upskilling of facilities managers, right? There needs to be a higher level technician level person there, or people there.
Yeah, well,
when I think about like NRL or Manitoba Hydro Building, the facilities people in those buildings are actually engineers. They're professional engineers running those buildings.
Right.
But because of that, there's a little bit, obviously, a different understanding, different operations, different skill set.
Yeah.
the buildings work. But we also know that even with that skill set within those architectures, that it took 2-3 years to fully commission those buildings to where they're working, where they are today, and they are working well. But it's a different building altogether because of the design, but also the people that are running it.
Yeah, so it was tweaked. The loop tuning was carried out perpetually, right? It was just evolved into a working thing.
Yeah.
I mean, yeah, let's be positive. There are a number of buildings, lucky enough, that I've worked on, which have been, which are just ticking away, and no one has to look at them. There are, and unfortunately, we do seem to have this very, very dark side of us where we like talking about negative things, unfortunately. And I agree with you. I think some of this stuff should come out that is highly positive and good for the society where we work in. But you unfortunately just hear these bad stories of bad things, and when you go back and you attribute them, they will come back for specific reasons, which are nothing to do with the controls, nothing to do with the design. Majority of them are done with the present day operation, which is financed by money.
Yeah. But going back to like a real world example again, like one of the projects that we're familiar with, the concierge was also the building manager, and the guy had a tough job. I mean, he had no mechanical skills, none. Like that wasn't his thing, right?
Right. Yeah.
He was great at operations in terms of the flow of vehicles and people, and dealing with all of the the postal stuff and all that kinds of stuff. But when it comes to actual conditioning the building itself, not his skill set, right? That's just way too much responsibility to put on somebody that has no skills. That's unfair. But building operators, building owners, condo boards, they do that to people all the time. So it's not the operators or the concierge problem. That's a building owner problem. Right?
It's also communication of how people communicate with it. I mean, way back when we done a school which was supposed to be sustainable. So what do? We done it. Here we go, radiant ceilings, and we done everything. And then what happened was there was a problem with one of the primary air handling units, which was a manufacturer's problem. And we get talking to the facility, the janitor people, and the guy's moaning about different stuff. And so I asked him, and he said, here's the simple thing. He says, if it goes, it's got a number on it. I get up on the roof and I look at the number of it. And what we do is we organize it. We get a new one. We don't even bother to repair it. We order a new one. At the same time, we get a crane in for a day. The crane cranes the old one off the roof, cranes the new one up the roof. We seal it all up. We're running again within 24 hours. He says, first of all, I can't climb in that cubby hole that the architect provided us, called the mechanical room, to have a look at the system. We can't pull the system out. We can't get the radiant panels to work because every time we climb out, there's so many books being thrown out there from the students on the top of the panels and everything like that. If you look at it, there's a simple thing. It's called horses for courses.
Yeah.
Horses for courses that sometimes you can go out and you can start doing all this different stuff. Back to the whole sustainable, the charrettes, they call them, with the sticky yellows on the wall, and let's do this and let's do this. And the best one I heard was low-E wallpaper, that you could put wallpaper on which would reflect. If you had a radiant ceiling, you'd have this low-E radiation reflecting. How about that then for a good one, yeah? Sorry, the energy is a bit high because the low-E wallpaper is dirty. We got to clean it. Where do we get to?
Yeah, no. Look, we're coming up on an hour and a half. Well, I want to be respectful of your time. So, and I also want to finish positively because you're right. We do. No, one of the reasons I started this podcast and I blog is because I'm so outraged at how bad our industry is. It stops me going postal, right? But also, there is an awesomeness to what we do, right? And there is a super awesomeness to like super tall buildings. But the more you know about how difficult that is, the more you just absolutely respect what it is, right? And I think one of the points you hit on is bang on. The industry is terrible at communicating how good that is, right?
Yeah.
And that's the point. The point is there are solutions out there. Yes, there's a lot of things to work on, there's a lot of things to change, but there are also great buildings out there, and there are buildings that work. It is not a unicorn, a building that works. It's just not an everyday thing either, right?
Right.
Yeah.
I agree entirely. You know what? Some of my, and I'm going to mention their names because they were really good. But John Goldtree and Alan Lott from IBE were really good. They never wanted to fence me. Well, they did occasionally. Never wanted to fence me and ask me to do something. And we're looking at, because it was always, you know, our pretext of doing a design was we don't want to end up in the law courts, and we didn't. You know, right? So where we are. One of the things that they did warn me on and told me about it, and they said when it comes up to there, they said, well, what do you go to ASHRAE for? What do you present all these papers, and why do you do everything for ASHRAE? Because basically you're presenting to your peers.
Yeah.
And I said, perfectly true. We're not, you know, we are. But however, what we're also doing is putting the bar higher and higher and higher. If we do something, we're showing the peers we've done this and we're doing it, or this is possible. You know,
Yes.
And that was, you know, again, back to ASHRAE several years ago, people would come and say, hey, you're doing this or do anything. I've actually had people, ex-presidents of ASHRAE have called me up and said, we're doing this job, Peter, we'd like to get you involved, you know, to have a look at something. And that's what we thought. We're to help each other.
Yes.
You know, the positive
Absolutely.
Where are we going to do? Have you done all this and done different stuff and all the stuff about the radiant floors? I mean, we won't go into too deep, but Robert and I, we've got so many scars of jobs we've done, which weren't done deliberately wrong, but were wrong. And the problem is, what people forget is, at that time, we had to resolve it there and then. Not by scrapping the whole thing, you had to resolve it. And that's the point that's missing from that. So yeah, it's out there. And one of the things about the book, and I will hang on the book, is I never got, I might get them now, never got any negative comments over the first edition. But people turned around and said this was wrong. But I mean, I do want to acknowledge now I had some very, very, very good people on that. They're very candid and knew what to do all around the world. And people from different things, even people that weren't really cognizant of the tall, super tall, mega tall buildings, telling me what they thought and what they would do when they were doing the things. And that's one of the things out there. So I think that's a good way of judging something.
Yes.
Right? If you, again, people are very, people would like, unfortunately, to comment and to go to the dark side than the positive side.
Yeah.
And we need to bring a bit more of the positive side. And if you've done something good, okay, then people need to turn around and say that. But that's one of the main things. So you know we've done it, and we knew what the holes were. I knew what the holes were, and I put it together. And we'll see what happens now. Apparently, it's selling. So, and that it wasn't my mum buying all the copies, by the way, anyhow. So,
well, I'm going to be buying a copy, and I'm going to be telling everyone in my network to do the same. So the thing. What I like about your book is it's such a good resource because it's a practitioner's guide. As you said, it's a how-to, right? It's not an abstract. So what I think the next step is for your book, consumers, please,
yeah.
You should do a training course, a series of video training courses or seminars.
Don't get me going on training courses, right? I got to be really careful what I say now.
Okay, don't get yourself in trouble.
It's very simple. All right, there was an what is the training called? Help me out here, Robert. I've forgotten it. ASHRAE has training courses, other things. What do they call it now? What?
Oh, the DL, the Distinguished Lecturer Program.
No. This was actually there.
ALI.
The ASHRAE Learning Institute. That's it. Yeah. So there was a tall building course. And of course, I got into it. The trouble is, this is where marketing and the real world get there. You can only do it in certain cities, right?
Yeah.
And so, where the hell did I do it? It wasn't Kansas. It was some remote place where I think the tallest building was about 30 foot high. You know, and we know where the architects are, where it's going to go. So I mean, it would be New York, Chicago, Los Angeles, maybe San Francisco, maybe London, and different things. I got invited by Swagon to go out to Moscow. We had 150, not in St. Petersburg, 150 people in St. Petersburg wanted to know about tall buildings. right? And do it. And that was it. I forget where it was now, but anyhow, bless their heart. And that's where it is. So, ASHRAE wants to try and do it where the conference is. Houston would have been very good. There's quite a lot of Houston. Not too much, I don't think, in Austin, but there are other places. And I think being involved on 9/12, which was a technical committee, when it was in New York, we actually got a whole morning session in New York where everybody could come in and have 3 or 4 different sessions and do their thing and actually get their continuing education, both for AIA and for engineers.
Yeah.
And so what better thing to do to broaden out and to go to the American Institute of Architects or architects that they could actually learn about different things. And you're not going to get it by doing it but I think it was in Kansas or some other place, which was, bless their heart,
Albuquerque.
Yeah, probably was Albuquerque. No, I forget where it was. But so it died of death, and
you need a manager. Someone needs to put you into you need to distribute your training on the internet and then do 4 speaking engagements a year with it, right? Like 2-day master courses.
Robert and I have talked about that, about doing some other stuff. But it's a good point. But I mean, yeah, I really think that it should come from ASHRAE, because I mean, I put a lot of time and effort into ASHRAE, and it's an ASHRAE book, and they should try and do it. And unfortunately, they're banging it again. Their marketing is it
is what it is.
Yeah, it is what it is. That's a polite word, didn't I?
And also,
tall buildings
are a niche within a niche within a niche, right? That's the thing.
But I mean, the other thing is as well, you can do lots of one-on-ones with people there that actually want to know you, and want to ask different things. And I've had some great conversations. I've done the lecture for I think the course was 3 hours, and sometimes one place I was there, I'll tell you where it was, of all places, Lagos in Nigeria.
Wow.
Well, they got it, but they want to do it. And they were going for 2-3 hours on questions. What about this? What about that? And you can do a lot offline.
Yeah.
You can turn and ask them, because they're not only asking you the technical things. I mean, that's the easy thing. Read the damn book. But the other thing is applications of it. And that's the key
that's how you learn, the backwards and forwards, the application discussions, right?
Yeah, absolutely.
Yeah.
All right, Peter, I want to thank you for your time. It's been awesome.
Peter, thank you.
Yeah, and look, we're going to do everything we can to plug your book, and I'm going to be buying it myself, and love it. Really, really impressed with it, because it is exactly what you need as a practitioner, right?
And not just for tall buildings. I mean, there's a lot of good fundamentals there too, right? So.
Well, yeah, that's it. We got another one coming out with Aaron McConaughey of ARAP. We've written the ASHRAE Design Guide for Natural Ventilation.
Right.
Which maybe we should talk about as well in the future.
That'd be another one, because we're getting into CFD and simulation jockeys, right?
Colours for directors, no. Leave them alone. Yeah. If, other than supporting plumbing engineers, if you want to waste money, right, go for CFD. Yeah. Here's the deal when I do CFD, and I'll tell you now, is very facetious and obnoxious, like I can be, is I turn around and said, if you have a CFD and you haven't got it on the screen and you don't like the results, if you get a magnet and go over the screen, you can change the colour. And there's always one person that tries it.
You should not put that out of the universe. People are going to do that.
Yeah, but that's as much as colours for director. What velocity you want? You want blue light? Yeah, blue light. Here we go. Yeah.
Okay, thanks very much. Best of luck with the book, and hope to speak to you again soon, okay?
Okay, guys, be well.
The Edifice Complex will continue in just a moment.
Robert, I have questions. Why aren't our buildings more like cars? Shouldn't our buildings warn us if something is wrong and could impact our health and safety? Why can't our buildings tell us how efficiently they're working? Why?
Well, they should, Adam, and they can. Our philosophy is designed for people, good buildings follow. this whole indoor environmental quality thing is becoming real important all around the world. Well, Tether have developed a mobile access property identity engine, and that enables landlords and property managers to monitor indoor environmental quality metrics plus energy consumption. It's all about making better decisions based on real-world information. Get smart, get tethered. For more information, go to tether.co.nz, and you can also hear from Tether CEO Brandon Van Blurk on our June 2020 episode of the Edifice Complex podcast.
And now, back to the show.
Adam, once again, we're lucky to have Peter Simmonds join us for a discussion, this time on tall buildings. He's an interesting guy, you know, and he brings a global perspective to the world of architecture and engineering, project management. And by the way, he just recently won an award, an ASHRAE award for international stuff. He made a comment which is so true, which was when the supply chain dictates design, then the first cost becomes the target. And we did some quick estimates that in North America, Canada, the United States, roughly 400,000 designs are done a year. Of those, 375,000 of them are done for projects less than 25,000 square feet by people who have no secondary education in engineering. They work for the wholesalers and the tradespeople. So they are part of the supply chain, and they do most of the design work in terms of quantity of projects.
Yeah.
And that's one of the reasons why we're driving to the bottom in terms of cost. And rather than good design, it's all about the lowest cost design.
Well, the race to the bottom has been won. It's been won by rooftop air handling unit manufacturers, right?
Yeah, sure, it's been won. So get over it. Let's move on.
I always remember being in a design meeting when I was Cobalt Engineering. So we were an MEP design firm. And the client was basically asking for the most sustainable building in the world with the budget for a K-12 school. So I sat in there for an hour, bit my tongue, and in the end I said, look, if this is your budget, we're putting rooftop units on it. Let's just select the rooftop units and end this meeting right now.
Yeah.
I couldn't get them to understand that what they were asking for was not what the supply chain can cough up at that price.
Yeah.
You know, you want a high performance car, you want a Porsche, you know there's a price to pay for that, right?
Yeah.
You want a high performance building, I've got news for you. You're not getting it for the same price as a piece of crap, office building you built for $400 a square foot. It's not happening.
No, and that's the thing is a lot of owners and clients, they in their mind they're building a Bugatti or a Ferrari or whatever, but what they get when they do the unveiling, or they smash the bottle against the side of the building to, christen it, what they get underneath is a ladder.
Yeah, exactly. Yeah, the drape falls away. And the Wizard of Oz is an old man. Yeah, exactly.
He made some really interesting comments in terms of oftentimes we get to talk a little bit about design, on the podcast here. He said tall buildings, because he was on talking about his new version of the Tall Building Guide, ASHRAE Tall Building Guide. He says, tall buildings is not one floor repeated 160 floors. That's not how it works. And says, as you go up a building, the climate changes. You can have completely different climate zones along the skin or the enclosure of that building, depending on what elevation you're at.
Yeah, I think this is one of my fears for tall buildings. They're iconic. They consume massive amounts of resources to put up and run. But I have a horrible feeling that in some parts of the world, it's a copy and paste. Well, we've got they get someone like Peter to do the concept design and they go, okay, Peter, thanks very much. You put him on a plane, send him home. Then someone does a copy and paste on every floor. Then they wonder why the top floors aren't working.
Yeah, absolutely. See it all the time. Well, and people need to understand, like we were talking in the course of the podcast, a kilometer high building.
Yeah. That's like 3 climate zones probably as you're going up that building. It has to be.
Like
right?
mind-boggling, right? Mind-boggling.
I would hate to be the person who has to test and commission and sign off the stairway pressurization system in that building. Can you imagine the stack effect issues in that?
That's huge. I mean, I've videotaped. I think you've seen some of the videotapes I have, the stack effect in buildings, and holy crap. I mean, people don't appreciate the pressure differentials that are created when you get into a kilometer-high building. We should ask them if he had any of the statistics, what kind of differential pressures. Well, I mean, what they do is they compartmentalize as they go up. They have to. They have to do it for mechanical systems anyway, right? Because of the pressures in the columns. But
you're a kilometer high, right? I mean, you're talking about altitude correction in your design calculations at that point, right? If you're copy and pasting, you're going to get in some deep trouble if you're doing that on top of that building.
Yeah. I don't remember off the top of my head, but I know when we did, like, for example, snow and ice melt design, and we were doing the radiation calculation, we had to determine what the sky temperature would be. And I don't remember what it is. At every 10,000 feet, you get a drop in temperature. I can't remember what that number is. But by the time you get to 25, 30, or 40,000 feet, obviously there's a huge difference in temperature, right, that you have to calculate. Well, whether you're doing a snow ice melting system and you're looking at the delta T for your radiation calculation, or you're talking about a tall building and you're looking at the delta T across the enclosure, there's that from the thermal perspective. But then there's also the pressure differentials that are created as well. And so it gets to be fairly complex in these buildings, not only from the building thermal side and, of course, air quality, but fire systems is huge, right? How do you move people from the top 1 kilometer down in a fire, right?
I mean, remember that film in the 70s, A Tower and Inferno, right? I was speaking to that, And the reality is you can't fight a fire over the maximum height of a firefighter's ladder.
No.
At that point, it's an evacuation strategy.
Yeah.
It's a suppression and evacuation strategy. Yeah. And, if you've got a kilometre high building, you're probably talking about helicoptering people off the building at some point, right? If it's really bad.
Yeah, you have to find some way. I mean, then we saw the consequences of the explosion. Yeah, right. What happened there? He also talked about some interesting things, the population diversity in these big buildings. I mean, they're their own culture within the building, right? I mean, you've got everything in there, and how challenging that would be for both the architectural and the engineering community to deal with the diversities that go on, right?
Yeah, absolutely. So the other thing that struck me was we all know who the star architects are, right? Norman Foster, Zaha Hadid, one of my favorites. We all know who they are. But who are the star engineers, right? So Peter is like the man, right, for tall building engineering, building design.
One of them,
best kept secret in the world.
Yeah,
right? He's written the book. He's the man. And why has he not got Norman Foster style fame? I don't understand.
Well, we've talked about this before. In fact, that was one of the, when I go back to the discussions when we first started this podcast, and we were in Albuquerque, New Mexico, in some bar having a drink, and you were talking about who's the Conor McGregor of the engineering world. And the reality is that they're very hard to find, but they do exist, and Peter is one of them. But we were talking about that. If you mentioned this, you said this, and I thought this was brilliant. If you think about, if you were one of the top lawyers in the world, or top heart surgeons, right, or one of the top tax specialists in the world, you are incredibly well known. You're incredibly well paid. For some freaking reason, that doesn't happen in the world of engineering.
No, it doesn't. Right? Yeah. So if you're the top heart surgeon, fill in the gap. Even financial guy, accountant, you're earning $500,000. Yeah, you're known, right?
Yeah.
You're a star. Not in engineering, man. No. Not in engineering. You're like a freaking, like an undercover agent. No one knows anything about you, right? And you're paid a government salary.
Yeah, and I don't know if that's what that's all about. If it's just a personality trait within the community that there's enough. Maybe I don't know what it is. I mean, when you think about the Starchitects, there is an element of ego in there and narcissism, right? So maybe that's what drives the pay fee. Is because you're paying for that particular persona. Engineers tend not to want to be in the limelight, right?
No, I think my theory on it is architects are artists, and society values art. whereas engineers do the embedded technology of that art.
Yeah.
So do I know about the printed circuit board in my calculator? No, only when it doesn't work, right?
Yeah.
So,
but Holly Chan, remember the interview we had with Holly Chan, and she talked about design as its own form of beauty. I don't quite remember the words it was, but you know, there's the beauty that we have in architecture, the aesthetics, the geometry that the viewer gets to experience when you look at it. But there is beauty within the formulas and the system designs
and the fact that it works seamlessly is a beauty unto itself, right?
Absolutely, it is. But it's under
hidden beauty. It's like beauty from within, right?
Yeah.
Yeah, it's like when your mom says, "Well, she's got a nice personality." You know, it's that beauty from within, and it is beautiful because it's seamless and unnoticed, and it's only noticed when it doesn't work. That's like the negative side of it. Yeah. Right? So if Peter messes up, you'd know all about it, right? But when he does his job great, it's, look at that tall glass building. That's awesome. Oh, that's a Norman Foster building. Well done, Norman. I know. We've got to somehow raise the profile of the project team and not have it dominated by the architect. The architect's important, don't get me wrong. There's no question about that. But that person's not working in a vacuum, that is for sure. Structural engineers, how they make that art possible. Who knows who the structural engineers are?
I mean, these guys, when they receive a set of conceptual drawings from the architect says, "Can you make this work?"
Yeah, and then they stop laughing after 5 minutes and go, "Well, I'll have a go."
And they don't change their fee. That's the thing, you know. It's like I don't know. Maybe they do.
I don't know. In my experience, you know, the structural fees are a percentage of construction plans, certainly in the UK, and you know, no matter how ridiculous that conceptual architectural drawing is, it's like, this is the percentage of your fee, and we'll see you when you've done the drawings then. But because I got a chance to, you know, Peter's a good friend of mine, and I had a chance over many, many years to work with him in conferences and listen to some of his case studies. And, you know, he did the Louis Vuitton Museum. And it's, you know, I mean, the architect basically, I swear to God, you know, he took a piece of paper and he just crinkled it up and said, "Okay, here's your building," you know. That's the Frank Gehry thing, right? I got drunk one night and fell on the model, and I like it.
and that's exactly what it was, you know. And so there's no, I mean, the geometry. Oh God. So, you know, but you need guys like Peter to look at that, because you've got multiple surfaces that there's nothing parallel or perpendicular in them. And how do you calculate lighting and sound effects and thermal effects in a room like that, where the energy flow is just bouncing like crazy? Like, it's just like a prism. It's like multiple prisms inside, you know, like, and so how do you deal with the stuff like that? And
I mean, that's a lot of experience. I've never worked on a super tall building or like a Frank Gehry odd shape. And they must be fascinating jobs to work on, probably very stressful, I no doubt, for a minute. But you know, the problems that have to be solved there are quite unique. Really interesting.
Well, there's the engineering challenges that go along, and then there's the personality conflicts. I know we worked on some Douglas Cardinal projects. Are you familiar with Douglas Cardinal at all?
No.
All right, so he's a Canadian architect of First Nations origin, and he does not work with buildings that have square corners. He likes the circular form, round curves, right? And you know, he did the Museum of Man in Hull, Quebec, for example. That was one of his projects. But you know, he got turfed off the project in Washington when they were looking at a museum there for because of personality conflicts. You know, and that's a challenge with some of these architects. Is, man, their ego drives a lot of stuff. But that's part of the creative mind, right? And
but they're not good with the word no, right? Or even maybe. It's not a word they like too well.
What do you mean you can't do this? What do you mean you can't make a circular building? And You know, it's got to be freestanding and
with no structural support. What do you mean, no structural support?
Yeah, you want beams and columns? What are you, freaking nuts? You'll destroy the. You put a beam or a column, you destroy the building. You know.
Yeah, I know it is nuts, man. But you know, people like Peter, just to say, more people should know his name. He is the Obi-Wan Kenobi of like engineers for high-rise buildings, and it is a travesty that not enough people know who he is, even though he's written the book. So, you know, the reason I like doing podcasts with people like Peter is because you can get their name out there, hopefully, and if you as a young engineer to model yourself on his ability, wouldn't be a bad thing.
Yeah.
Would not be a bad thing at all.
No, because he received that award, that international award from ASHRAE, which is a good recognition to have, because very few people could be eligible for that, to have that kind of influence. You know, one of these days we got to get on Thomas Auer from TransSolar, because he would be also a guy that would be eligible for that award, because they've done work all over the world. And you know, TransSolar, I mean, amazing design firm. And so if anybody knows Thomas and wants to get him on, we'll be happy to
absolutely
to chat with him. But you're right, Peter is one of those guys. And you know, I mean, the thing about the papers and that he's published, I mean, I was reading through some of his lists, and we've actually collaborated on resource lists, particularly as it relates to radiant cooling and heating systems, because that's been one of his bag of tricks in his portfolios for, I mean, as long as I've known the guy, right? He loves that world, and as we both do. I mean, it's an elegant way of conditioning people inside of spaces, and hundreds of papers, you know, that he's written on it.
He's we got to put him out there. Anyway, man, I was so glad he came back on, because first time we spoke to him, we went down the radiant rabbit hole in Bangkok Airport. So it was really good to talk to him about tall buildings, and because that's his signature, if for want of a better word, right?
Yeah.
Yeah.
Oh yeah, absolutely.
Okay.
He's also, you know, very cynical of the world of legal, getting your ass sued, getting long letters, the 14-inch paper that comes in a long envelope.
Yeah, no, he's obviously butted heads, I'd say, with a few people in the course of his career. And, you know, that can take chunks off you, because when you challenge the status quo pushes back on you. Right?
Yeah.
And, you know, when you're building, you know, $100 million plus building, the risk starts getting a bit serious, right?
Yeah, it does. I remember one of the businesses I bought was from Brian DeJager, he was an engineer, geologist by trade, actually, reservoir engineer. And we were negotiating the deal, and we were talking about goodwill and due diligence. And he said, "Yeah, Robert, if a what do you say? If a 14.5-inch envelope shows up at your door, don't sign for it."
Yeah, that's right. Are you Robert Bain? No. No.
So thanks, Brian. Thanks. You know, here. Yeah. So, anyways,
that's good. That's wise wisdom, actually. That is wise. I like
that. Totally. Well, and the thing is, and you know, like I've had. Been drawn in on a couple of court cases where we had no responsibility at all, as was found out by the judge during the examination for discovery in court cases. But you know, people need to understand that for young kids that are getting into the field of engineering, that you don't have to be directly involved with a failure, but you will still get called into court if your name is on the documents or you have something to do with the project. And I remember there was a fire at one of the ski lodges out here in Banff. This is going back probably 25 years ago now, 30 years ago. And we had nothing to do with the building design. We had nothing to do with the mechanical systems. In fact, we had nothing to do with the supply of the components, but because we were the representative for the manufacturer, we were asked to go out to the project to do an inspection on the gas train. And I was not a gas expert at all. This is a lesson for people listening online. And my spidey senses said to me when the owner of the manufacturer of the product came up and said, "We need you to go to the job site." I said, "No, like I do not want to be involved in this project at all." And after his persistence, I finally gave in, which I shouldn't have never done. I ended up on the job site, and we're in the mechanical room, and there's these great big 3, water heaters that are there. So the general contractor was there, the mechanical contractor was there, the guy that actually bootlegged the products into the province was there, and they're looking at me and they go, "So Robert, what do you think?" I said, "I think they're white," because they were white, and they wanted me to give them some advice on these things where they were firing it correctly, and I just said, "I'm just no freaking way I'm going to say anything about these things other than I'm going to observe the color of them." Yeah. And I knew at the end of the day that this is never going to go well. Anyways, I get up the next morning, turn on the radio, and Norquay Ski Lodge burns to the ground. And I just said to my wife, "Kiss your ass goodbye for the next 2 years, because we're going to be hauled through this." And sure enough, the 14-inch letter envelope came along. We got named in a lawsuit, which eventually we were absolved of any responsibility because we didn't make it, we didn't sell it, we had nothing to do with it, but we were there on the job site, and so you get called in. And so that's a lesson to engineers, is that you need to be careful what you say, what you do on a project, because you will be tagged.
I've been involved as a developer in legal actions, and what happens is, everybody who remotely touches that job gets brought into the action. Yeah. And they assess everyone's insurance, and then it goes from there.
Yeah.
Who can pay, who can't pay, who's liable, who's not liable. It really comes down to who can pay and who can't pay.
Yeah.
But everybody who's involved in that job gets called in, gets joined in the action, to use the terminology in there. Good luck with that.
Yeah, absolutely. Yeah.
And that's why from the hip, right, when you do that.
Oh yeah. And so there's, again, one of the lessons there is that documentation is incredibly important. So, we as a habit, like I log my phone calls. I don't know if you guys can see this, but I have a book here that I use. Anyways, I log, time, date, who it was, what we talked about. If you do that consistently, the courts will use it, accept it as evidence in the case. Mm-hmm. And so because I had recorded my phone calls, that was subpoenaed, and they used it, and it helped us actually in the end. So young engineers, if you're listening to this, or any professional really, you have to be able to demonstrate your contributions or not.
Yes.
In a project, right?
Yeah. You've got a communication, right? Okay, man. So on that note, Peter's awesome. You should bend the knee and worship him, and buy his book, is what I got to say.
And a beer, if you ever see him.
If you ever see him, buy the man a drink.
Buy the man a drink. He's got lots of wisdom, and for anybody that's up and coming, if you get down to the conferences and you run into him, it's harder and harder to do because he's semi-retired now, right? So I don't know if we'll see him at the conferences anymore, but by all means, get the book, read his papers, study his work, because there's very few people like him in the world.
True that. Fact check, true. Okay, see you on the next one.
All right, Adam. For the slice.
Bye.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. If you have enjoyed this podcast, please leave us a review on iTunes. See you next time.